This lecture is focused on the different scales of units that measure temperature and how to convert between those scales. So temperature is a way to measure the average kinetic energy of the particles that are in a sample. And so it's related to heat because heat is another form of energy transfer, but it's not exactly the same. Since these are different properties, you can't directly convert between heat and temperature. So temperature is measured in degrees Celsius, degrees Fahrenheit, or Kelvin, which are not degrees Kelvin, just Kelvin. This drawing on the bottom of page 20 in your note packet shows how the different temperature scales are related. The Celsius degrees, the degrees Celsius, and kelvins are the same size. So going from 0 to 100, 100 Celsius is the same space as moving up 100 Kelvin from 273.15 to 373.15. So the size of the degree Celsius and the Kelvin are the same. They are just offset. They're offset by 273.15. So to get back and forth between degrees Celsius and Kelvin, you need to either add or subtract 273.15. And a good way to remember which is remember that the Kelvin can never be negative. So we don't want to subtract 273 because then if the Celsius is a small number, you can get a negative result. So since Kelvin is never negative, we have to add. Celsius can be negative, so for the Celsius we should subtract. This 273.15 is now defined and exact. So if you wanted to, you could use 273.15000 as many zeros as you want. So this is not completely correct, this in your note packet. The conversion from Celsius to Fahrenheit is also exact. By that I mean this 1.8 is an exact number. You can use as many digits as you want. And also the 32 is an exact number. That has as many digits as you want. So the 32 and the 1.8 are not limiting you to two significant digits. They don't limit you at all, actually. Just your Fahrenheit or your Celsius measurement is what's going to be limiting you. So I've given you my trick for remembering whether to add or subtract the 273.15 with the Celsius and Kelvin conversion. For the degree Fahrenheit, I just remember that Fahrenheit is always going to be a larger number, a higher temperature than Celsius. If you've ever looked at the temperature in Celsius anywhere, it's usually a much smaller number. So I know that to get the Fahrenheit, I have to have a bigger number. And the way to make something bigger is to multiply. If you multiply by 1.8, then that is going to make something bigger. Dividing by 1.8 will make it smaller. Multiplying will make it bigger. And then once I've made it bigger with multiplying, I make it bigger with adding. So both of these things make it bigger to give a Fahrenheit value that's a bigger number. So that's sort of how I remember this one. And then I can solve for the other one by subtracting 32 from both sides. So I subtracted 32 from both sides to get just 1.8 times degrees Celsius on the right, the Fahrenheit minus 32 on the left. Now if I divide both sides by 1.8, then I get this equation, which is the same as the other one. So these equations are ones that you have to be able to come up with and also use. So those are my tricks for coming up with them. We're going to need to be able to convert between Fahrenheit and Celsius, and also to convert between Kelvin and Celsius. So if you remember that 0 degrees Celsius is the freezing point of water, and also 32 degrees Fahrenheit is the freezing point of water, these two temperatures are equal. So this is something that you can do to double check and make sure you have the right equation. If you put a 0 in here for degrees Celsius, it should come out to be 32 degrees Fahrenheit. with this equation it does, so this is the right equation. So we have 32 degrees Fahrenheit matching up with 0 degrees Celsius. Then for Fahrenheit, there are 180 degrees to get from the freezing point to the boiling point. For Celsius, it only takes 100 degrees Celsius. So 100 degrees Celsius covers the same distance that 180 degrees Fahrenheit covers. So for every 1 degree Celsius that you go up, you're actually going up 1.8 degrees Fahrenheit. So that's where the 1.8 comes from. All right, let's practice a few of these problems in the note packet to make sure that we understand. The freezing point of water I mentioned is 0 degrees Celsius or 32 degrees Fahrenheit. So if that were on the list, that would be one of them. Also, 0 degrees Celsius is about 273 Kelvin. So these two would be the freezing point of water in Celsius and Kelvin. This is in Fahrenheit. So let's try converting a Fahrenheit temperature into Celsius. So to do that, we need to subtract 32 from the Fahrenheit and then divide by 1.8. Subtracting 32 gives 343, and also looking at the significant digits, we know to the ones place on our Fahrenheit measurement. The 32 is exact. I didn't underline that because there's no uncertainty here. This could keep going on forever. And so our uncertainty in our answer is in the ones place. Now this becomes a division problem where I have 3 significant digits in the numerator, infinite in the denominator because the 1.8 is also exact. It could go on forever. My calculator gives me a bunch of digits. We should round to 3 significant digits. So that is 191 degrees Celsius. If we want to, we can keep this intermediate value to convert to kelvins because our Kelvin is going to be our degrees Celsius plus 273.15. Let's go ahead and add this. So we come up with 463.70555 known to the ones place. So our Kelvin would be 464 Kelvin. We'll round that to the ones place. So we have our temperature in degrees Celsius and also in Kelvin. So for this next one, to get degrees Fahrenheit, we need to multiply our degrees Celsius by 1.8 and then add 32. So 29 times 1.8 plus 32. Our 29 has 2 significant digits. It's known to the ones place. These other factors are both exact. The multiplication gives us 52.2, but only with 2 significant digits. So we have uncertainty in the ones place. If we add 32 to that, we get 84.2, but the uncertainty again is in the ones place. So we should round that to 84 degrees Fahrenheit. So for the Kelvin, it's the degrees Celsius plus 273.15. So the degrees Celsius is the 29. When we add that, we get 302.15, known to the ones place. So that should be 302 Kelvin. Okay, so for this last one, we're starting with Kelvin. We'll go ahead and convert it to degrees Celsius first by subtracting 273.15. We're going to get an answer to the ones place. So that's negative 196.15. If we want to report this, we should round it off to be negative 196 degrees Celsius. When we convert it to Fahrenheit, if we like, we can use this intermediate value. just keeping track of where the significant digits are. So we can use negative 196.15, but just keep in mind that it has 3 significant digits. So this becomes negative 353.07 with 3 significant digits. So our uncertainty stays at the ones place. So that should be reported as negative 321 degrees Fahrenheit. So these are our 2 answers to those conversions.